Okay, so in this video I'm going to show how the polytropic relations for an ideal gas are derived. You may have seen in textbook or in some problems that they use these relations that kind of look complicated, but actually this is pretty simple to derive. So everything is based on exactly what the title is saying: polytropic relations and ideal gas. So what is a polytropic? The polytropic relation is PV to the K equal to a constant. So if we use that relation, what do we have? P1 V1 to the K equals P2 V2 to the K. So basically this would be our first relation. And what would be the second one? Ideal gas. So what is an ideal gas? So the ideal gas will be PV equal RT. So basically that will mean we can write down P1 V1 equal RT1, but we can also write down P2 V2 equal to RT2. Okay, let me just rewrite this one. Let's say under this form: P2 over P1 V2 over V1 will be equal to what? T2 over T1. So basically now it's just a matter to know what is the information that we want to keep and what is the variable we want to eliminate. So let's say we would like to derive this expression here, T2 over T1 equals to V1 over V2 K to the minus 1. So that means that we need to eliminate the variable P. So then what we can do is that from equation 1, we can write down P2 over P1 will be equal to what? P2 over P1 will be equal to V1 over V2 to the K. Now, from the second expression, we can write down P2 over P1 will be equal to T2 over T1 V1 over V2. So now we have two expressions equated to the same thing. So if we equate this equation here to this one, then we will eliminate the pressure. So let's say here, equating, what do we have? V1 over V2 to the K equal to T2 over T1 V1 over V2. Okay, and from here we just need to write down T2 over T1. So we're trying to get that relation. So T2 over T1 will be equal to V1 over V2, okay, to the K. Oh, and now when we move this one, we get V2 over V1. But we can rewrite this as T2 over T1 equals to V1 over V2 to the K times V1 over V2 to the minus 1. So that at the end we have T2 over T1 equals to V1 over V2 to the K minus 1. which basically it is what we were expecting. Okay, so we should derive two more relations. Let's say T2 equal to P2 over P1 k to the minus 1 over k, or we can actually just derive this one over here. So let's try to do this one over here, which looks a little bit more complicated. So that means that we need to eliminate the T2 over T1. Okay, so actually in order to do that, we cannot go directly from here to here. We're first going to have to equate T2 to this expression, eliminating V, and then just say that these two expressions should also be equal to each other. Alright, so basically what we do at this point is that from the first equation, this time we try to eliminate the volume. So from the first equation, which will be this one, we can write down what? So basically the same thing as we did before. We can write down, let's say, P1 over P2 equals to V2 over V1 to the k, or this would be equal to what? P1 over P2 to the 1 over k will be equal to V2 over V1. Alright. And from the second expression, which will be this one, we can write down that what? V2 over V1 will be equal to what? T2 over T1, P1 over P2. So you see, once again, we have two expressions for V2 over V1, so we can equate one to the other. So we write down equating. We'll have T2 over T1, P1 over P2 equal to P1 over P2 to 1 over k. So this will give us that T2 over T1 is equal to P1 over P2 1 over k times P2 over P1, or as before, can write down T2 over T1 equals to P1 over P2 1 over k times P1 over P2 to the minus 1. So this will give you what? T2 over T1 equals to P1 over P2 to 1 over k minus 1, which is the same as P1 over P2 to 1 minus k over k. So let's see, is that the expression we needed to find? No, they have P2 over P1. Okay. Alright, so basically this is actually the same thing. So T2 over T1. So if we reverse the order over here, okay, this would be equal to P2 over P1 to, we need to reverse the sign over here, k minus 1 over k. Okay, just for clarification, if it's not 100% clear how I went from here to here, I just want you to remember that you can actually write what? Let's say 1 over x is actually equal to what? X minus 1. So basically what I go from here to here, what I do is I have minus 1 minus k over k, which will give me k minus 1 over k. Alright? So at the end, since T2 over T1 is equal to V1 over V2 over k minus 1, and T2 over T1 is equal to P2 over P1 k minus 1 over k, we can say that we have proved that V1 over V2 k minus 1 will also be equal to P2 over P1 k minus 1 over k. Alright, thank you so much for your attention.